Hello and welcome to the 14th episode of Polprog's Electronics vlog. Today we're gonna take a look at this Westermo TD32B, a rather mysterious and unusual looking device. Well, some of you might already know what this is. It's pretty obvious judging by the connectors on the front panel. This is a industrial grade dial-up modem. So this is pretty much the device that you would use to be able to remotely access your plant. Nowadays, its function was mostly superseded by TCP/IP connections, remote desktop protocol, and other ways of remotely accessing a computer system. But in this day and age, this would be the simplest way to gain remote access to a plant. So we would connect this to some sort of, maybe even a control computer via the serial port. On the front panel we've got an awful lot of blinking lights for diagnostic purposes. Most of the pins like transmit data, receive data, are ready to send, data carrier detect data, terminal ready and data set ready. They have a control light as well as the telephone connection. We've got a power controller, a power indicator, line indicator, answer and relay. The modem comes in a typical DIN rail enclosure, so the height of this is standardized and the width as well. On the back you've got a standard DIN rail mounting. On the top we've got a cover that lifts. The case is a bit broken, we're gonna fix this. And inside we've got an absolutely huge amount of dip switches for configuration of this thing. All of the terminal blocks on the front are connected in modules and they are removable for ease of installation purposes. I've actually removed the power connector so that I can connect a mains cable to this thing. The top connector is also removable, and on the top 9 terminal blocks you've got basically every single line of RS-232 broken out so that you can connect it to another piece of equipment that doesn't necessarily use the D-sub connector. You also have a leased line connection, 4-wire connection here. And as I said, on the front you've got a classic telephone line jack and a DB25 typical modem connector. So as I said, the terminal blocks are removable. This is the mains connector. It's got a protective cover on it, which covers the exposed wires. So if we plug it in and then turn on the power, you can see that it's waking up. There's the relay clicking, and well, that's pretty much what it does now. So let's go ahead and connect it to a computer and the telephone line. I've connected the modem to the laptop, and as soon as I run Picacom, it opens the serial port and we've got the RTS pin going up. For some odd reason the modem was actually configured with 4800 baud. I guess that's there is an option to configure it for automatic baud detection using the dip switches on the top. Alright, so I've managed to find out what was wrong with it. So first of all, it was set to 4800 baud, which we found out previously, but additionally it was set to leased line answering mode, and that's why it was not answering any of the AT commands. So if we now run Picacom on the TTYS0 port, we should see the RTS light over here go up like this. We set it to my 600 baud, the one and only correct baud rate in the entire world, and we can start issuing AT commands. So we've got AT, okay. So the modem is answering AT commands fine, but it cannot dial anything because it's not getting any dial tone. Well, this is an issue, but mostly because there's no phone line connected to this modem. So how do we get a phone line with a dial tone? I'm gonna show you in a moment. In order to connect a pair of modems, you are looking for something that does the role of an Ethernet switch in a phone network. Or, speaking specifically, you need this. So with the setup, I've got the modem connected to jack number 1 on the PBX, which is internal number 101, and I've got a telephone connected to another jack. I can dial the modem's number. The PBX is ringing. After 2 rings, modem answers. We can initialize the carrier tone. And the modem is answering. But not everyone is crazy enough to actually have a PBX at home. So we can connect 2 dial-up modems without a PBX, provided that you set them up properly. And pretty much this boils down to setting ATX3 on the receiving modem, which disables stuff like dial tone detection, etc., and allows you to just dial in with another modem without any of the local loop signaling stuff. So that's actually how I made the Rick Astley modem video, dialing 0118-999-881999-911-97253. This modem is connected to the other computer, and I'm using Minicom instead of Picacom on this one, because the other part to that video is to actually pipe the TXT file into the into your transmitting modem, and Minicom allows you to do that with Control A Y, and give you a quick selection prompt to select a file, and you press enter and it just pipes it in. This gives me time to actually set up the transmitting modem. And on the transmitting modem, you need to enter ATA as in the right moment, which is as soon as the receiving modem stops dialing the number. So well, let's try it, shall we? So here I've typed in ATDT and the phone number. When I press enter, it starts dialing. And now I need to type ATA here. So as you can see, they have connected. We've got Connect 9600 here. Typing the keys on this laptop makes them appear on the other one. So now I just do Control A Y. I select the file containing the ANSI out of Rick Astley. And it starts piping the contents of that file into the other computer through the modem. This is pretty much what it boils down to. So yes, if you have 2 modems, you can use them to connect 2 old computers which are too old for Ethernet, or just connect them for, well, fun, without a PBX, provided that you're fast enough and you set up proper settings on both of the modems. Well, the only thing that's left is to fix this little guy up quickly, and we're good to go. So just a bit of epoxy, tiny bit I hope you liked this video. If you did, then certainly leave a like and subscribe. That's all for now. See you in the next episode. Cheers!
31 seconds.